Let's discuss the certificate tracking system and linking certificate linking system that we have proposed for this research work. Here, every electric vehicle is also have a key pair, public key and private key. And after that, the second entity is network certificate authority, one who issues the network certificate to the electric vehicles. It also has his private key and public key pair. Initially, electric vehicle who wants to join in the network creates a request. Okay, the request is the combination of real-world identity encrypted by the public key of NCA, so that only the one who has private key of NCA can open it. Okay, and the second thing is the public key ID of electric vehicle and the timestamp at what time it is the request has been generated, so that NCA can easily monitor at what time that particular request has been generated. Okay, after that generation of request, uh, after creating that request, EV sent that request to the NCA. And when NCA received the network certificate authority receives that particular request for the certificate, the first step it does is to check if any other existing it decrypts. The first step is it decrypts the message, decrypts the request, and gets the real world ID and as well as the public key ID. So on the basis of that, the NCA checks whether there is some already existing certificate or not. If there is a certificate is already existing certificate with that ID, the NCA ignores that particular request. In second case, it also checks the status code. Status code is a kind of a code that we have introduced, which represent the different kind of previous historical stages of that particular ID, that particular IDs previously issued certificates. Like if certificate was zero, that certificate is a valid one. Okay, if the status code is one, then the normal expiration, that means the certificate uh, is expired normally according to the expiry date given by the NCA. If the status code is 2, then the revocation request by the user. This revocation request by user is used when a user feels that his certificate or the public keys or the keys has been stolen or attacked by some malicious attacker. And third, the status code is 3 when the revocation by NA. In this case, if this status code is when and NA find out that that particular certificate user is involved in some kind of malicious activities. The status code is 4 when uh, there's some one more step like a bad count. I will explain in after some time. Okay. If an NCA found out that the status code is either 4, that means it is blocked due to the malicious activity, or the bad count. Bad count is a number of times, number of chances given to a particular user to be good. Or if after that, if just for example, if network set the bad count to be 2, that means after getting two times revoked by NA, the NCA completely blocked that particular that particular identity. That means NCA will be no longer issue any kind of network certificate to that particular real world identity, because it found that that particular user has been involved in malicious activity twice. Okay, so that's why this is the bad count. That's the bad count set by the network or the NCA. If everything is good, that means the status code is good and the bad count is not as set by the network. So or the no or no previous record of that particular ID exists. In this case, this is the NCA will be start generating the certificate linking variable, which is theta I. Okay, theta I is actually the a combination, that's an encrypted one, that contains the real identity of the user, the public key of that particular user, and CID, that's a certificate ID, and C bar ID. C bar ID is actually the current certificate ID, and CID is the previous or the past certificate ID. I have applied the similar kind of linking concept as a blockchain used to link the blocks. Okay, so in this case, if it is first time issuing, you can see in the picture, this is the actually the linking of certificates. This is a linking of certificates. When NCA issued the first time, NCA issued the certificate first time, there is no previous record. In this case, the CI or CID becomes a zero certificate. Just like a Genesis block, it is like a zero certificate. That means no previous or no past. Sorry, previous, not previous. Past certificate is existing. Means this is the first copy. Okay. In this way, there's a link is created between the past certificate and current certificate. Okay. After that, mu, another variable is created, which links between the certificate and the timestamps, and this that mu actually combines the four factors. It combines the linking variable, a public key of that particular user, and timestamp at what time it is created, and the expiry status, expiry date, and the status code. And then that mu I is actually encrypted by the NS private key. This is also used as an authentication system by other users. If other user want to authenticate or verify that the user who want to communicate with me is a valid or not, he can easily decrypt. Easily decrypt mu I using the public key of NCA, and figured out if the status is 4 or 3. That means the user it might not be a trustable one, or the user is if 1 or 2. If the status is 1 or 2, that means the certificate is no longer valid. Means the user has to communicate to the one only if and only if the phi I or the status code is 0. Otherwise, no communication. Okay, and the certificate is actually the combination of mu I and the expiry date, and the status t status and mu I. The phi I is actually the status code. It is encrypted as well as added. Look, there is one more concept that I want to bring in your notice, which is we have included phi I here also, and we have included phi I here also in a mu I, which is because if if a malicious user want to tamper, he can easily tamper or change that mu I, because it is in the certificate form. But he cannot change the mu I, the phi I inside that particular mu I, because it is encrypted by NCA. Because it is encrypted by NCA's private key, so it can be only decrypted by NCA's public key. So the third user can easily verify it, but a malicious user cannot alter or tamper with it. So it again provides another layer of security. Okay, and the bad count is initially when a fresh certificate is created, the bad count is set to be 0. Okay, and there is one more concept that we have introduced, the automatically that means automatically certificate status checking. NCA will perform a certificate check on entire network certificate database uh, time to time, so that it can easily detect all the certificates with phi equals 3. If user is found in malicious activities, or the phi equals to 3, then it will increment the bad count by 1 and the revoke the certificate. Okay, that means there is a double penalty: the revocation of certificate and the bad count increment. So it will be a little bit more restrictive for the user who think to be a malicious, who think to execute some kind of malicious activity. Okay, if the byte count or b is equal to the value set by the network, and the phi equals to 4, then they block the real world identity. This is a situation which completely block the that particular certificate from requesting for certificates. Sorry, blocks the real world identity from requesting the new certificates. So in this way, this method provides a different layers of as a barrier or a security layer, and it automatically checks the network for the some malicious activities, or user, and block the user who has been found with some kind of malicious activities, involved in malicious activities, to protect the network. Okay, we can say certificate tracking system as well as a status code concept to protect the certificate issued to the user in the network by the network certificate authority, which is NCA. So this is the it about the network certificate tracking system. If you have any kind of query or any kind of suggestion, please you can reach out to us, or we love to hear your questions or suggestions. Thank you.